Related signals using one name. Vectors are used to group related signals using one name to make it more convenient to manipulate. For example, wire 7 o'clock W declares an 8-bit vector named W that is functionally equivalent to having 8 separate wires. Notice that the declaration of a vector places the dimensions before the name of the vector, which is unusual compared to C syntax. However, the part select has the dimensions after the vector name as you would expect. Wire 99:0 my_vector // declare a 100 element vector sign out equals my_vector 10 / part select 1 bit out of the vector. Build a circuit that has one 3-bit input, then outputs the same vector, and also splits it into 3 separate 1-bit outputs. Connect output O0 to the input vector's position 0, O1 to position 1, etc. In a diagram, a tick mark with a number next to it indicates the width of the vector, or bus, rather than drawing a separate line for each bit in the vector. Module declaration. Vectors are used to group related signals using one name to make it more convenient to manipulate. For example, wire 7 o'clock W declares an 8-bit vector named W that is equivalent to having 8 separate wires. Type specifies the data type of the vector. This is usually wire or reg. If you're declaring an input or output port, the type can additionally include the port type, e.g., input or output, as well. Some examples. The endianness, or informally, direction of a vector is whether the least significant bit has a lower index, little endian, e.g., 3 o'clock, or a higher index, big endian, e.g., 0:3. In Verilog, once a vector is declared with a particular endianness, it must always be used the same way. E.g., writing vec 0:3 when vec is declared wire 3 o'clock vec is illegal. Being consistent with endianness is good practice, as weird bugs occur if vectors of different endianness are assigned or used together. Implicit nets. Implicit nets are often a source of hard-to-detect bugs. In Verilog, net-type signals can be implicitly created by an assign statement or by attaching something undeclared to a module port. Implicit nets are always 1-bit wires and causes bugs if you had intended to use a vector. Disabling creation of implicit nets can be done using the default _net type none directive. Unpacked versus packed arrays. You may have noticed that in declarations, the vector indices are written before the vector name. This declares the packed dimensions of the array, where the bits are packed together into a blob. This is relevant in a simulator, but not in hardware. The unpacked dimensions are declared after the name. They are generally used to declare memory arrays. Since ECE 253 didn't cover memory arrays, we have not used packed arrays in this course. See http:// http. Accessing an entire vector is done using the vector name. For example, assign w equals a takes the entire 4-bit vector a and assigns it to the entire 8-bit vector w. Declarations are taken from above. If the lengths of the right and left sides don't match, it is 0 extended or truncated as appropriate. The part select operator can be used to access a portion of a vector. W build a combinational circuit that splits an input half-word, 16 bits, 15:0, into lower, 7 o'clock, and upper, 15:8 bytes. Module A 32-bit vector can be viewed as containing 4 bytes, bits 31:24, 2316, etc. Build a circuit that will reverse the byte ordering of the 4-byte word. This operation is often used when the endianness of a piece of data needs to be swapped, for example, between little endian x86 systems and the big endian formats used in many Internet protocols. Build a circuit that has two 3-bit inputs that computes the bitwise OR of the two vectors, the logical OR of the two vectors, and the inverse, not, of both vectors. Place the inverse of B in the upper half of out underscore not, i.e., bits 5:3, and the inverse of O in the lower half. Bitwise versus logical operators. Earlier, we mentioned that there are bitwise and logical versions of the various Boolean operators, e.g., NOR gate. When using vectors, the distinction between the two operator types becomes important. A bitwise operation between two n-bit vectors replicates the operation for each bit of the vector and produces a n-bit output, while a logical operation treats the entire vector as a Boolean value, true equals non-zero, false equals 0, and produces a 1-bit output. Look at the simulation waveforms at how the bitwise OR and logical OR differ. Even though you cannot assign to a wire more than once, you can use a part select on the left-hand side of an assign. You don't need to assign to the entire vector all in one statement. Build a combinational circuit with 4 inputs in 3 o'clock. There are 3 outputs. Out underscore in, output of a 4 input and gate. Out underscore R, output of a 4 input or gate. Out underscore XOR, output of a 4 input XOR gate. These are timing diagrams from some of the test cases we used. They may help you debug your circuit. The diagrams show inputs to the circuit, outputs from your circuit, and the expected reference outputs. The mismatch trace shows which cycles your outputs don't match the reference outputs. 0 equals correct, 1 equals incorrect.